So today's lesson is focused on combining like terms with rational numbers. Essentially, this means that we are going to be combining like terms that are fractions. Okay, so those are the types of rational numbers we're working with. So to begin, we need to know how to work with fractions. So for your warm-up, you have numbers 1, 2, and 3. Please pause this video, complete the warm-up, then come back and check your answers. So you'll notice that for our warm-up, for number 1, because we're adding, we had to find like terms. For number 2, you multiply straight across, and then always remember to reduce if possible. And for number 3, notice that I switched them into mixed numbers, or from mixed numbers to improper fractions. And then when I added them, I had to reduce them with their common denominator, and I ended up getting 5, 6. So to begin today, we have a little bit of a review, but in a different manner. There's some different words we're going to be using. And so over on the right-hand side, you'll notice we have some vocabulary to discuss. The first word is opposite. And we talked about opposite numbers earlier this year. One example could be 3 and negative 3. And so what you need to know is if we have opposites, if it's currently a positive, its opposite will be negative. Or if it's currently negative, its opposite will be positive. The next thing we need to talk about is sum. Remember, if we take the sum of two things, we are going to be adding them together, okay? So, in our directions, it says to write the sum and then write an equivalent expression by collecting like terms and removing your parentheses. So to write our sum of 2x and negative 2x plus 3, the first thing we're going to do is take our expressions that we currently have and we're going to put them in parentheses. And then if we sum, that means we're going to add. So if I would write this, I have 2x plus the negative 2x plus 3. The next thing we need to do is make an equivalent expression by combining like terms. 2x and negative 2x would combine, and those are opposites, and they actually cancel, so our answer is just a 3. In the next problem, we're taking one expression as 2x minus 7, and our other expression is the opposite of 2x. So if I would add these together, I have 2x minus 7, 2x minus 7 plus the opposite of 2x. So because it's currently positive, its opposite will be a negative 2x. When I combine my like terms, 2x and negative 2x are opposites, so they cancel to make 0, and my answer is just the negative 7 that's left over. And last but not least, we have the opposite of 5x minus 1 and 5x. So to write that, I'm going to write the opposite, or minus 5x minus 1 plus 5x. When I go to combine these, remember that negative is really a negative 1. We have to distribute that in first. So negative 1 times 5x is negative 5x. And negative 1 times negative 1 is positive 1, plus that 5x on the end. When I combine my like terms, those cancel because they're opposites, and my answer is simply positive 1. Today we're going to transfer ideas from those first two slides and apply them to the rest of our lesson, combining rational number like terms. Looking at number 1, are those like terms? Well, yes, because they both have the same variable, which is y. Our next question is, since we're adding, do they have common denominators? That's also a yes. So we can go ahead and add. 4 plus 6 is 10, and that gives me 10/7 y. Now let's take that the next step and change it into a mixed number. How many 7s fit into 10? One whole group of 7. And if we pull out a group of 7, we'd have 3 leftovers. So an equivalent answer would be 1 3/7 y. You could check by making it back into an improper fraction to make sure that you converted it correctly. Number 2 is very similar, except you have to make common denominators. So please pause the video, find your common denominators and your answer, and then come back and check. You'll notice that my common denominator was 12, so I made that into 8/12 n minus 9/12 n, which equals negative 1/12 n. For number 3, you're going to do the same thing, except remember, first we're going to have to change 2 2/9 into an improper fraction. So the problem we're really working with is 1/6 n plus 20/9 n. And my hint for you is our common denominator in this case is going to be 18. Please solve the problem, turn it into a mixed number, and then come back and check your answer. So when solving, our numerators become 3 and 40. When we add them together, we get 43/18n. And we want to change it back into a mixed number. 2 groups of 18 can be pulled out. And so that leaves us with 43 is what we started with, and we just took away 36 items. It leaves us with 7 leftovers over 18, and then our final answer is 2 7/18 n. Our next slide is a story problem, and this is going to be really an intro into working with those fractions. So as I read, I'm going to annotate. At a store, a shirt was marked down by $10. A pair of pants doubled in price. And after those changes, the price of every item was cut in half. We have to write two different expressions to represent the new cost. Notice we are going to use S for the shirt and P for a pair of pants. So, the first thing I'm going to look at is my shirt. A shirt was marked down by $10. So I'm going to take S minus 10. That is my shirt. A pair of pants, or P, doubled in price. Doubled is timesing by 2. But rather than saying P times 2, I'm going to write it as 2P since it's more efficient. And if I'm buying both these items, I'm going to go ahead and add them together. Okay? The next thing says that every item in the store was cut in half. So if I'm going to take half of this, we are going to divide by 2. However, dividing by 2 isn't always the best way to write this. Instead of writing dividing by 2, I'm going to multiply by 1/2 since it's the same thing. So my first expression is going to be 1/2 times S minus 10 plus 2P. So that's one expression. My second expression is going to be found by distributing 1/2 and multiplying. So 1/2 times S is just 1/2 S. Remember, smash them together. Then I have minus 1/2 times 10. Well, half of 10 is 5 plus, and 1/2 times 2P. Well, 1/2 of 2 is simply 1, and then I have my P. But we don't have to write the 1, so I'm just going to put P. So here are my two expressions. They both show the cost of buying a shirt and a pair of pants. Next, in example 3, we have to write our expressions in standard form by combining like terms. So essentially, do what we've been doing, we just have fractions. So remember, whenever we see parentheses, we want to distribute first. Okay? So I am going to be taking on my first arch in purple. I am taking 1/5 times 3/4 x. Well, if I multiply straight across, that gives me 3/20 x. My second arch in blue is 1/5 times 1/2. That gives me a positive 1/10. Those are not like terms, so that's my final answer. In step 2, we're going to start the same way. Ooh, but notice we have 2/2. We can't work with 2/2 the way it is. So the first thing we need to do is change that to an improper fraction. So we're really dealing with now 5/2 times negative 3/5 x plus 1/3 plus 2x. Now we're going to start it the same way. We're going to start by distributing. 5/2 times negative 3/5 x. When we multiply straight across, that gives me negative 15/10x. However, those can reduce, and why don't we reduce to make it easier on us? And by dividing by 5, we end up with negative 3/2 x. My second arch is going to be 5/2 times 1/3. If I multiply straight across, I get 5/6. It can't be reduced, and it's positive 5/6. And don't forget to add 2x on the end. Next, we have to collect like terms. So I have an x and an x. When I add these, negative 3/2 x plus 2x, think of it as 2/1. We have to find our common denominator, which is 2. So I have negative 3/2 x, and if I make it into 2, we have plus 4/2 x. When I add these together, negative 3 plus 4 is positive 1/2x. Now, that's what our x's turn into. But we can't forget that we still have to add plus 5/6 to come to our final answer. Lots and lots of steps to get to an answer, but it's doable. Our last two problems today are very, very similar to the last slide, except these I want you to try on your own. So pause the video, use your last slide in the notes as a reference, but complete these answers and then come back and check your work. When combining an A, we used distributive property, and then we didn't have any like terms, so my answer was simply negative 1/4 minus 1/2 y. In part B, we did the same thing, we just distributed, and when I did so, I got 1/12 f minus 4/9. Those are not like terms, and so that's my final answer.